you know, if you see something like H2CO, who goes in the middle? Who's going to go in the middle? Oh, we better look at our chart again. Who goes in the middle? So carbon's going to make how many bonds? 4. Oxygen will make 2. Hydrogen will make 1. So who's going to go in the middle?
Carbon.
Yeah. So my strategy is to have something like this, right? That would be my strategy. What if let's do something else like that. What if I had H2C2F2? Does that look, yeah. Who's going to go in the middle? Oh, let's check our system. Fluorine's only going to make 1, and hydrogen's only going to make 1. So
C's going in the middle.
yeah.
F is going to at least one of the carbons, and H is going on the ends.
I have 2 carbons. What do I do with 2 carbons?
They're both in the middle.
Yeah, so I'm going to have 2 carbons in the middle. And then, you know, technically without direction, you could have 2 H's on one side and 2 F's on the other side, but you could also do an H and an F and an H and an F, something like that. That would be my strategy, right? And that's kind of the idea. I'm not going to finish. I'm going to leave those for you guys. I think I've done the whole set. Does anybody have any? Let me actually stop the recording, and this will be for you. So let's just review real quick. So while we're at it, so good ideas is to pair unbonded electrons, show bonds with sticks, maximum of 3 bonds between any 2 atoms, usually a maximum of 4 bonds on any single atom, like that, right? Usually atoms will achieve an octet, meaning 8 electrons. There's special cases that are not 8. Avoid rings unless you have 3 or more carbons. You need a minimum of 3 carbons to have a ring. Usually 5 or 6 is where they really tend to happen, though. If you have a negative charge, you're going to add electrons to the outside. If you have a positive charge, you're going to remove electrons from the inside. Your strategy is usually to find an atom, put an atom in the center, and have other atoms outside of it. Use a pencil. We also saw, let's see, that for main group atoms, the number of valence electrons was equal to the group number, and that gave us a bonding pattern, which is really important for doing this set of steps, where carbon and atoms below carbon tend to make 4 bonds. They'll usually be in the center. And if you don't have a carbon, then a nitrogen would be in the center. And if you don't have a nitrogen, then probably an oxygen, or a boron. If you don't have a nitrogen or boron, then you probably have an oxygen in the middle, and so on. And then finally, for Lewis structures, we kind of had a set of principles. So we're going to put the atom that makes the most bonds in the center, put in valence electrons to make obvious bonds, check octets, key rule, and then check total valence electrons. If both of these are correct, then you probably have the best Lewis structure. There are some follow-up steps. If these are not both correct, then you want to do extra steps to make the octets match what they should be and make the valence electrons match what they should be. If it's an ion, you'll have to put a bracket around it and double check before you do your final answer.